Okay, functions and data analysis fans, our topic for today is Unit 1-9, compound interest. Before we start, let me tell you your joke of the day. How many lips does a flower have? And the answer is 2 lips. 2 lips. Haha. Okay, we did the front together. And what we did was we looked at simple interest, a situation where if you have an investment of $1,000 and the interest rate is 10%, and we're talking simple interest over a period of 10 years. So depending on from 1 year, 2 years, this is the amount, the total amount you would have after that period of time. So basically, each time you're going up $100 because 10% of 1,000 is $100. So under simple interest, at the end of 10 years, you would have $2,000. Compound interest, though, is different. With compound interest, you're calculating your interest, and then you're adding that on to your amount to get a new amount, and then the next time you calculate your interest, you add it on to the new amount. Okay, so what happens is that at the beginning, we invest $1,000. After 1 year, we now have $1,100 because we did 10% of 1,000, and we got $100. So the new amount is 1,000 plus 100 is equal to $1,100. Okay. Now, for year 2, though, we're going to take another 10% interest, but it's going to be using this amount right here, not 1,000 again, but using our new amount. And so this time what happens is when we calculate 10% of 1,100, now suddenly our interest for that year is not $100, it's $110, it's gone up. And then we add that to the original amount for that year, which was $1,100 at the beginning of the year, and now you have $1,210 is the new amount. So what happens with compound interest, by the time we get to the 10th year, that $1,000 has become $2,593.74. Under simple interest, it was $2,000. So what compound interest does is it calculates the interest more often, and it adds it on, and your amount keeps growing, so that each time you calculate it, you have a higher principal to start with. And what's happening here, we graphed it, okay, we already did the graph. Simple interest is going to be this linear function right here. But what happens with compound interest, look at the curve. This is what we call an exponential function. And notice that we have a lot more money with compound interest than we do with simple interest. Okay, so that's something that we've already talked about. We've already looked at these. So now we're going to do the back of the notes. So we're going to flip this over. And now we're going to look at how you actually calculate this with a formula. So the compound interest formula. Now you see there are a lot of variables here. It's a lot going on. So let's explain what these mean. A is the amount after a number of years. Amount after number of years. Okay, so that's what you end with. That's how much you have at the end. P, that's your principal, which is the starting amount. Okay, so that's what you have at the beginning, at the start. R is the interest rate. Now that's going to be written as a decimal. So remember, you got to take a percent, you got to change that to a decimal. N is going to be the new variable here. N is the number of times compounded in 1 year. In simple interest, we just calculate interest one time a year. But that's not how things always work. If you have a bank account, a savings account, that's going to be compounded once every month. So that would be 12 times a year, so N would be 12. You may have certain things, credit cards, the way credit cards work, it compounds daily. So 365 times a year, they're calculating interest on your principal for that. Okay, and then n times t, this is an exponent here. T is the time in years. And then again, n is the number of times compounded in 1 year. And what happens here, so let's say we have 3 years and we compound monthly. Okay, so 12 times per year. The number of times we're going to calculate this would be 12 times 3. So for 3 years, you would actually calculate your interest 36 times. Okay, so let me show you how you use the formula here. So in number 3, let's do an example. Calculate the amount of a $2,500 investment at 6% for 3 years, if it is. And then we're going to do a bunch of examples here. Compounded annually. Okay, so compounded, now annually means once a year. So on the side here, let's write down what these numbers represent. The investment is $2,500. That is the principal. So the principal is $2,500. The interest rate is 6%, which is 0.06. Okay, we're going to use that 0.06 for our rate. The time is 3 years. So we're going to invest for 3 years. So t is equal to 3. Now, compounded annually means the end value, the number of times we compound in 1 year, is 1. Okay, so not very exciting, but we'll start with that as an example. So here we go. We're going to use this formula. A is the amount, equals the principal, which is $2,500, parentheses, 1 plus, it's the rate divided by the number of times being compounded. The rate is 6%, 0.06, over n, which is 1, close parentheses, and then this whole thing is going to be raised to the n times t power. So it's going to be raised, the exponent would be a 3. 1 times 3 is 3. Now you can type this whole thing in. So if we do that, we would take 2,500 and then parentheses, 1 plus, and I'm going to hit alpha y equals to set up a fraction here. It would be 0.06 divided by, so put that over 1. You can use your arrows to get to here. I'm going to hit my right arrow, close parentheses, and then that's going to be raised to an exponent. So to do that, I'm going to hit this button right here. Okay, raised to the... Now I can hit 1 times 3, but I can also just hit 3. And then when I hit enter, so after 3 years, our investment will be $2,977.54. So the amount is $2,977.54. Now what happens if we take the exact same situation, I'm going to go to part C here, the exact same situation, but we want to compound monthly. So think about how many months are in 1 year, and that answer is 12. So we're going to use the same variables for P, principal, the rate is 6%, the time is 3 years. The difference is that now the end value is 12. So I'm going to set up the formula. 2,500 is the principal times 1 plus, it's the rate divided by the number of times compounded in 1 year. That is now 12, raised to the n times t power. Okay, so up here the exponent is n times t, n is 12, and the amount of time is 3. Okay, so now I'm going to type this again, 2,500, parentheses 1 plus, 0.06 divided by 12, whoops, got to be careful here. So I'm going to come down, 0.06 over 12 divided by 12, close parentheses, and then my exponent raised to the 12 times 3, which would be 36. So you could just type 36 there. 2,991.70. So the amount is 2,991.70. So what happens here is that by compounding it 12 times per year instead of 1, notice that the amount is higher by about $14. So you make more money when you compound it more times. Okay, let's do part E where we compound daily. So ask yourself, how many days are in a year? Well, that would be 365. So n equals 365. Again, I'm going to set up my formula. The principal times 1 plus 0.06. Notice the only thing that changes is the n value. So this time, 365 days in 1 year, raised to the 365 times 3. The days in the year times the number of years. That's the number of times we're going to recalculate our interest here. Now I can do something with my calculator. If I hit second enter, it recalls what I've typed previously. So I can go back into this and just change. I want to change my denominator to 365. That's my n. And then up here I want to change 12 to 365. I'll just retype 365 times 3 just to save time, and we enter. Now this will be $2,992.999. I'm going to round that up, and when I do that, this actually becomes $2,993. So the amount is $2,993. The important thing to recognize is that the more times that you compound your interest, the more money you're going to have. Look at how the values go up. Not by a lot necessarily, but over a period of time that can make a difference. Okay, I'm going to save the right side for you. So let's go to number 4 here. Find the total value of the investment after the time given. So in number 4, let's say we have $12,000 that we invest, 14% interest rate, well that's amazing, compounded monthly for 5 years. Before you start writing the formula, I would write down what all your values represent. So the principal is $12,000. The interest rate is 14%, which is 0.14. Compounded monthly for 5 years. Now 5 years is the time. Compounded monthly, there are 12 months in 1 year. Okay, so those are the numbers that we're going to use. So the amount equals the principal, 12,000, parentheses 1 plus, it's the interest rate divided by the number of times compounded per year, which is 12 monthly, raised to the n times t, 12 times per year, 5 years. Okay, and now it becomes a calculator problem. Be very careful as you type this, 12,000 parentheses 1 plus. Let's say alpha y equals to get my fraction so I can type it like a fraction, 0.06 over, sorry, 0.14, wrong problem, 0.14 over 12. Okay, close parentheses, and then raise to the 12 times 5. And we hit enter, and we have 24,067.31. So the new amount after 5 years would be $24,067.32, because it's 0.317. So I'd round this up to 0.32. So basically your investment would double in 5 years if you could get this interest rate compounded monthly. That's pretty darn good. All right, let's go ahead and stop part 1 here, and then we'll finish up with part 2.